Hi, welcome back to another episode of Gadolinium Journal Review. This is where patients are reading studies that have been published about gadolinium, and we're just trying to connect the dots, understand more about what's going on inside our body, comparing the research that's coming out to our personal experiences as patients following one or more injections of a gadolinium-based contrast agent, which is used in imaging. So if you're not familiar, there's lots of information, and we have all kinds of studies published and can help you out there. Anyway, these, as I mentioned, this is like a 3 to 5 minute review of an article that I've read as a patient. You might see the same journal reviewed by other patients, and they may have some other takeaways from any given article, right? Because different things resonate with different patients as you read about these things. So and we're just trying to make sense of all of it, trying to figure out why our health isn't what it used to be and how we can get back to being healthy and living the life that we once had. This article, 3 to 5 minutes I do this, and we'll post the links, okay? So please do your own homework and research. 7T, MRI and molecular studies of doderum retention in macrophages. So doderum is a macrocyclic. There are also linear brands out there, but this one is specific. This article is specifically focused on doderum. So interesting in the abstract, the very second sentence of the article says, free gadolinium is very toxic. That's something that patients really deserve to know before they it is injected into the human body, because it is retained, and that's factual. Those studies are everywhere. It's retained in the brain, the bones, the tissue, and the organs. So you want to know. That's something you'd want to know, right? That it's toxic. Let's move on. So the next part of the article is talking about gadolinium and calcium are very similar, and that gadolinium can compete with calcium. Compete with calcium. So as we understand it, calcium is a nutrient that everyone needs and is used in the human body to maintain homeostasis. If gadolinium is competing with it and gadolinium is then retained, is it replacing the calcium? Is it in a strong arm and it's like all of a sudden replacing it? Anyway, it competes with it, and it impacts the regulation of cellular function. Well, patients will tell you that's probably really true, and the article just stated that, so let's believe them. I'm just only going to just spend a minute talking about this because we keep these 3 to 5 minutes. There's lots of acronyms. I encourage people to always, when you're doing these research articles and reading them, you're going to run into all these acronyms that don't make any sense to you as a patient. So you're going to find yourself doing some Googles and trying to understand it. And you may get it right. We may get it right. We may get it wrong, but we have a little bit more understanding, and we know that knowledge is powerful. But anyway, there's lots of acronyms here. One is the RHOA, which has to do with it regulates cell growth and metabolism of cell survival and proliferation. Well, that sounds pretty key and critical to humans. Anyway, so then we go on and it talks about actin cytoskeleton. And when I went in to look at that, it took me into several other terms and everything. But what I deciphered from all of that was that particular term refers to and is critical for cell functioning. And specifically, and that's where I'm going to leave this review, is it's has to do with muscle contractions, cell movement, cell shape. So as I read, and it's saying that the binding is prevented and it can disrupt the calcium signaling pathways, leading to impaired cellular functions such as muscle contractions and neurotransmitter release and overall cellular homeostasis. Wow, that's huge, right? And why it made sense to me and why I'm calling it out, and that's where I'll end this video. And I encourage you to do more research. But in our community, we have a lot of people who videotape their muscle twitching and their fasciculations. And those are disruptive to people and their ability to walk to have energy, to all kinds of things. And it's interesting to view some of those when twitching's going on in your arms or in your legs, and you don't know why it's twitching. And it's anyway. So the article talks about that. That's kind of cool. Points it out that it is a real thing. The other thing it talks about in the article is the mitochondria and how this is disruptive to the mitochondria. Well, we know that the mitochondria is the powerhouse for our energy levels. So that makes sense too from this article that I've read. And I'm going to tell you the article is 6 pages long. It's very technical and it may not make sense to a lot of people. I shared it with a friend who's in the group and he's like, it doesn't make any sense to me. Debbie, can you explain it? And so we talked about it, and really, we're not experts, but this does, kind of confirm a lot of the things that we are dealing with as patients. So the mitochondria is the powerhouse for energy, and so it makes sense when reading this article. One of the takeaways, and I'll leave it here, is because I'm over my time, is the mitochondria, and the mitochondria is really the powerhouse for energy. That would explain why patients all the time are saying, I just don't have any energy, chronic fatigue, all those things, right? So I encourage you to go out and read these articles. Pick one, there's hundreds of them, and just kind of like map it to your own symptoms and side effects or associations, and maybe it'll help lead to some more new and open dialogue as we, as gadolinium's just not hit the radar yet. We hope that this is helpful, and we encourage you to come back and listen to some more shorts. I apologize for going over time. Once again, thanks for listening.